Multi-tenant applications allow you to manage a single database system for multiple customers. For such a system, you can use your database in one of two ways. You can manage separate databases per tenant, or you can establish markers on the data that says this data belongs to tenant A, this data belongs to tenant B, and so on. The big challenge you face is when you wind up with a lot of commonality when each customer wants its own special look and feel for their system. Other challenges to multi-tenancy include having different data which must be kept isolated, having to handle shared data, managing different business rules and behavior for each user, being able to guarantee your customers that despite all the moving parts, everything will just work. Today, RavenDB CEO Oren Eini talks about the exciting features in RavenDB 5.0 that let you tackle these multi-tenancy challenges in your applications. You will see how you can scale up significantly across many tenants, how you can share data between locations, how you can move a tenant from one database to another database. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone, thank you for joining me. Hi everyone, and thank you for joining me. So I had to reboot my mouth. I'm here today to talk about multi-tenancy. And multi-tenancy is a really interesting problem. But before we get into how we can resolve that, let's talk about what it actually is. So multi-tenancy is a single application that is being used by many tenants. Now, tenants are not users. Twitter is not a multi-tenant application. Facebook is not a multi-tenant application. By multi-tenant, we typically mean that there is some concept, a company, an organization that has multiple users that use the system. And you have multiple such organizations, each one of them, for each one of them, the system behave as if they were the sole proprietor of the system. And a good example is something like Basecamp, CRM system, CMS, and things of this nature. WordPress is a good example, or WordPress Online is a good example of a multi-tenant system, because each user have their own effectively copy of the system. Now, one way of actually getting to multi-tenancy is have a single tenant application and just deploy that multiple times. Have n databases, and web server, and app servers, and stuff of this nature. That works, that's relatively easy to handle, but there is a lot of redundancy here that we don't want to pay for. So typically, multi-tenant application have a single data layer, a single set of applications, a single set of web servers. Now, it's interesting because there's so much commonality between the different tenants, and yet there are also lots of differences. For example, it's very common in multi-tenant application that each tenant want to have their own look and feel on the system. Luckily, today you can do that mostly with CSS file. Other things may be different rules and requirements for different tenants. If we're talking about something like Basecamp, backtracking, or something like that, there may be different workflows between tenants. Or for Northwind, vacation approval must be authorized by a manager of rank C and above. In Contoso, it can be approved only by the direct manager, whatever. I'm not going to talk about those changes. Workflow, look and feel, user changes, not my field. I'm going to talk specifically about how do we deal with data being different between tenants in my application. And let's see what are the challenges that we have to deal with. So the first thing that we have to deal with is that it's very bad, like bad, if one tenant has access to data from another tenant. If a user is seeing data that it's not meant to see, it sucks. If a tenant sees data from another tenant, it's greater than sucks. It's completely broken as far as the system is concerned. There is, in multi-tenant application, there is very strong separation of the data, and you should never be able to see data that doesn't belong to your tenant. There is also a mapping of users to tenants, and then you have to make a determination. Do we have a user per tenant? Or let me rephrase that. Is a user account bound to a single tenant? Or can we have a user account that belongs to multiple tenants? And a great example here may be, again, a bug tracking system. In a bug tracking system, I may be working on multiple projects at the same time. Each project would be a tenant in the system. So, but I don't want to have separate users for each one of them. I want all of them to behave normally as I run them. So this is absolutely something that I have to take into account. And funnily enough, as important it is to have separation of data between tenants, I also really want to share some data between them. A good example now, this data may be stuff that is globally shared. For example, in an accounting system, I may want to share the tax rates and the applicable VATs and all bunch of stuff like that. But I may also want to share data that is generated from the tenants themselves. A good example here might be something like, oh, I have a CMS system, and maybe I want to implement some sort of ranking for a CRM system, not a CMS, some ranking for contacts. And if one tenant says something like, oh, this person is nasty and he doesn't pay on time. So maybe it goes into ranking, and when some other tenant sees access that or enter the details about this contact, they see a note, hey, another user has said this is so-and-so. I'm not sure if this is the right example, but that's the one that pops to mind. So there is this funny tension between, oh, I want to have data isolation, but there is also very big importance to being able to share very carefully and explicitly data across tenants. And finally, there's all sorts of reports that I have. A good example might be, okay, I want to see how many contacts I have in the system, how many emails were sent globally across all of my tenants. Those are admin operations, but I still need to somehow make them. And there are also user visible reports, and that might be something like, oh, my system sent 3,000 payment requests today, and you should join the revolution in payment processing or CRM or schedule or whatever the app may be. Okay, now let's see some strategies to handle that. And there are basically two common ones. And the first one is to have the notion of a tenant ID. Every single or almost every single entity in the database has this field. And you can see that we have an actions, and Bake Cake belongs to Contoso, Buy Milk to Northwind. All the tenants reside in the same database. That means that whenever I'm querying, I have to query with the applicable tenant ID. On the other hand, if I want to do cross-tenant queries, that's very easy for me to make. The other option is to have a database per tenant. And you can see it here. We have two separate databases, one for each tenant. Note that this is database, not cluster. This is really important. A RavenDB cluster can contain many nodes, and each node can contain many databases, and a database may span multiple nodes. So in this case, you can see that Contoso runs on node B and A, a node or node C and D. In this case, we are looking at a 5-node cluster. And each tenant is its own database. That gives me great separation between the tenants because I would have to go and query the completely wrong database for me to actually get some other people's data. But and that tends to be much harder. Let's see what are the advantages or disadvantages of doing that. In a single shell database, there is a lot less to do. I have to do less development. I have to think less of operations. I can just run with everything. Something that is really important is that I have the notion of shared resources. Try to imagine that each one of my tenants is using 10 megabytes. And I have 200 of them. So let's look at the math. So I'm using 2 gigabyte, 200 megabyte of data. Now, in practice, I would probably use something like this. So a total of 2 gigabyte and not 200 megabyte, 2000 megabyte. Now, why is it important? It's important because I have a single set of indexes. I have a single set of a file on disk. Things become much easier. When we're talking about multiple multiple databases, one per tenant, then we have per database cost that we have to deal with. So the fact that I have shared resources allows me to pack a lot more tenants into a single server or single cluster. It's also much easier to do cross-tenant operations. Now, the disadvantages are quite big. The primary one is that we have to talk about data leakage. How do I absolutely ensure that we don't leak data from one tenant to the next? Other problems are around backups. I have a tenant that comes to me and says, oh, I want a backup of my database, of my data, because it's not his database, it's just his data. And now you say, okay, I have to write something to extract just your information from the backups. If you need to delete a tenant, that's also something that you have to write on your own. Encryption is something that you can only do at the database level with RavenDB, or you can do that on the client side. It also means that in terms of customization, each tenant typically have different behaviors. And when you're running all of them in the same database, RavenDB has to accommodate all of those behaviors. If you are running separate databases, we would be able to optimize separately for each tenant. Now, there's also a size and scale issue here that we have to consider. If everything is on a single database, if all of my tenants are on the same database, at some point I'm going to hit the limit of what I can handle. Now, it's not that bad, because even when you're using a single shared database, or when you're using a shared database, it doesn't mean that you have to go with a single shared database. It's actually quite common for you to say something like, okay, I'm using the shared database architecture because it allows me to do a lot of cross-tenant operation, not much of other stuff. But I'm ready to say that if I have a tenant that is big enough, I'm going to move it to its own database. That's an interesting decision to make, because it means that now you have to deal with some of the disadvantages of running with a database per tenant. So let's look at that. The first thing that is good, we have physical separation of the data. It's also much easier to do a per tenant backup, encryption, customization, the whole thing. If a customer comes to me and says, oh, I want my data, I can give him a backup of just his database and says, here, everything that I have is on here. That's very easy. If I have a big tenant, someone that is really hammering the system, it's trivial for me to move them to their own hardware, to a dedicated hardware, without needing to actually change anything in the system. And then we have the indexes are optimized and a whole bunch of other stuff like that, where Raven is actually able to adapt directly to what that specific tenant is doing. Now, the disadvantages is that we have higher per tenant resource utilization. It means that we use more disk, more memory, threads, all of that. It also means that if we have to query across tenants, we have to deal with much more complexity. Now, let's talk about the limit number of tenants per node. Let's see why is that. Let's say that I'm talking about something pretty small. I'm talking about 250 tenants per node, and each tenant is 1 gigabyte and has to deal with 15 requests per second. Now, let's translate those numbers. That means that we have a 250 gigabyte total data set. It means that we have to deal with 375,000 requests per second. Now, each one of them is going to go to a different database. So there is almost no chance that we have caching optimization opportunities. Now, even if my database has 64 gigabytes of RAM, if each one of my 250 tenants is hitting me constantly, my working set is guaranteed to be bigger than RAM, which means that I have to hit the disk. Now, looking at that, you would say, oh, this is a pretty bad scenario because just for 250 tenants, I can see that I'm going to be drowning. But this is actually a really interesting issue because notice that not all of them are going to be used all at the same time or the same frequency. In fact, most of them are going to be idle most of the time. And even when they're being used, they tend to not being used concurrently. So that helps us a lot. Another thing that it allows us to do this. Oh, I have Northwind. I move that to its own dedicated nodes. Now, moving nodes in RavenDB is something that you do on the fly. This is an admin operation. You can actually add a node to the cluster on the fly and then set up this database to move from node C, which is busy, to node D. And when it is done, he says, oh, I want you to always use node D for Northwind. And that will be it. Now you have a dedicated node for this big tenant, and you're done. Now, this is when we're talking about big tenants, but it also applies if you need to rebalance your cluster. You started with 3 nodes in the cluster, and you have 250 of them. So you have about 80 tenants per node. Now, some of them, we have, let's say, 8 on each node that are being very busy. So you're able to go to 250 tenants divided by 5 servers. So you have 50 per node, and this is something that the admin can manage on the fly. Everything is going to run normally, and the application doesn't need to change. You actually don't even need to change the connection string because we know how to go to nodes that aren't in our connection string. Now, let's see how we actually start here. And there are 2 ways to identify a tenant. One of them is to have something like this, northwind.myapplication URL. And what the idea here? The idea here is that from the get-go, I have the user telling me what is the tenant that they're going to be using here. AWS is using something very similar with their account system. But Azure, on the other hand, uses this model where you have a user and then the user is attached to multiple subscriptions. So in this case, you have to make a decision. In this case, I have a user who is only attached to a single tenant, but they can have it attached to multiple tenants very easily. Now, in your application, after you've done the login authentication, you have to have some way of saying which tenant this is. And I'm going to assume that you have something like this, an async local for the tenant ID, and that is going to be initialized on every request to your application from the session, from an encrypted cookie on the user, something like that, that tell me what tenant I have, and that get initialized at the very start of the request lifecycle, because that's important for everything else. Samad is asking, can you talk about how the application will learn about the new node without updating the connection string array? Okay. This relates to how RavenDB knows about topologies. Let's see if I can show it easily. If you go here, you can see that we have the notion of, in this case, we have just a single node, but we have here a topology. The very first request that I'm going to be making to the system yes, because I need to spell. When you start RavenDB client, you tell it what connections, what URLs to use, and what is the database name. And it's going to go on the list of URLs that you gave it, and it's going to get this, the list of URLs. Now, notice that this URL doesn't have to be the same URL that you have here. It may be different. And it's not required to be in the set of URLs that you have. This is intentional because at that point, you're able to say, oh, I know about node A, B, and C, but this database now live on node D. So it just work. Now, in addition to doing that on the first request, this is dynamic. You can ask RavenDB to modify that on the fly. You can add nodes to that if you have more nodes in the cluster. And whenever the database updates the topology, it means that the system will update all of the clients on the next request, and they will get the new topology. This is why you can update this on the fly, and RavenDB will just run with that. And you can add a new node to the cluster, and it will show up in the topology update operation, and the client will start referring to that. Okay, so we have the notion of tenant ID. It's being set up somehow in your application. If you're doing this, this is obviously from the host name and etc. You know how to deal with that. Now, this is how you set up a RavenDB document. So this is the client API. And you can see that here I have all of the 3 tenants. And the question is, what database should I be using? This is the same across single and shared nodes. When I'm using a single shared database, I'm putting the shared database name, and that's it. Now, there are a few things inside of RavenDB that allow me to handle okay, we have a question from Ganesh. This would be the case if you use a single database for multiple tenants. Yes, this is what we see here. A single database that uses multiple tenants. But I want to make sure that I never access a tenant that I don't own. So notice what I'm doing here. Before every query, I'm saying and tenant ID equal to the tenant ID that I have, which means that automatically all of my queries are tenant-based. Now, this applies only to queries, but maybe I'm doing something else. I'm doing load, includes, those sort of things. For those, I also have this, after conversion to entity. And I have two interfaces in my system. One of them is tenanted, which is data that has per tenant existence. And I have I'm not tenanted marker, which is data that is globally shared. That might be something like the VAT rates, tax rates, those sort of things. Now, these two make sure that I'm only getting my data, and this ensures that they have a failure if I'm trying to access someone else's data. And you can see just two calls, you set it up at the beginning of the system, and everything just works from there. In a multi-database system, this is what I got to do. I got to say, whenever I open the session, which database I'm going to use. And that's where it ends. There's nothing else that I have to do. It is really common to actually have two databases in use in this point. One of which is the global database. It contains metadata, it contains all sorts of interesting information about the system at large. And then you have the tenant database, which contains the tenant data. So you typically have two of them, not just one, but same. How do you set up a new tenant? In a single shared database, you create the relevant documents, and that's pretty much it. You select a new tenant ID, you create a tenant document, and you're done. In the case of a database per tenant, you have to create a new database. You have to decide where it will go. You can let RavenDB decide that for you, obviously, and we do its best to balance things. You can set up an encryption key, you can set the backups. There is some work to be done. But once you've done this work, it's typically smooth sailing from there on. Database encryption. This is something that in many cases, users really want to have. And in the single shared database, you can have a single key that will be managed by RavenDB and used to encrypt all of the data. It's important, by the way, to understand that RavenDB always encrypts all the data in the database. That means that we encrypt the documents, we encrypt attachments, revision, time series, the whole thing, and that includes indexes. So RavenDB indexes are encrypted when you're using an encrypted database. Now, if you want to have encryption per tenant, you have to do it yourself using client-side encryption. With a database per tenant, you have the ability to set up different keys for each tenant. Note that the backups are also encrypted. An easy way to handle backups in such situation is to tell the user, hey, do you want access to your backups? Give me an S3 buckets, a GCP drive, Azure blob storage, whatever, and I will upload to your location, which is owned by you, managed by you, all of that, the data, encrypted with your key. And you can rest assured that your data is safe in your hands. If you want to do the same thing for the single shared database, you have to write quite a lot of code. Tenant deletion. Single shared database, you have to write a lot of code. You can't touch the backups, and this is important. Deletion is expensive. It can be even really expensive. And that matters because you may be impacting the performance of the entire system. Typically, deletion in a single shared database means that you're setting a flag that, oh, this tenant has been deleted, and then you're deleting the documents 1,000 at a time to very slowly drain all of the documents that you have in the system. That also touch on what happens if you need to do more complex things. If you have to have indexes, specifically static indexes per tenant, and you deploy all of them on a single shared database, that's probably not a good idea. because they would be triggered on every single entity change, not just on their tenant. Even if they actually do the filtering, they would still have to run in order to do the filtering. A tenant per database, delete the database, delete the backups because they are separate, because they are per database backups, and that's it. Now, what happens if I have a single big tenant? We discussed that. We move them to their own node, but that's easy in the, that's relatively easy to do. If we're running tenant per database, that's trivial. If we're running the single shared database, that's more complex, because now we lose the single shared database. But what happens if I have scaling issues around multiple users, multiple tenants? And none of them is too big, but we need to scale across the entire system. We can rely on RavenDB to do that if we are using database per tenant. And let's see how it works. You can see here we have a 5-node cluster, and here is a tenant, the helpdesk tenant, 1, 2, 3. Fulfillment is 1, 2, and 3. So in this case, I have 5 nodes, and each tenant is replicated 3 times. I've seen users who go for 3 nodes and a double application on all manners of things. Notice, by the way, that RavenDB clusters can grow to much larger sizes. You can have a 50-node cluster with a replication factor of 3. It would work. And that is a nice way of scaling in this case. Now, what happens if I'm using the single shared database model? And it turns out there are ways of scaling that. So this is a new feature in RavenDB 5.0. We haven't made much noise about that, but I really love that. I really love this feature because it's very much to the point. And the idea here is that I can either register to this event, which will apply on all sessions, or I can set it up on a case by case for a session. And it just tells me, give me a string that would give me a context for this session. Now, remember that in this case, all of the nodes in the database are, so all of the database contains all of the tenants, sorry. Now, what does this do? What it does, it means that I have a shared database topology of A, B, and C, and it's permutate the topology based on the context that you provided. So as far as Node is concerned, the topology is BCA, and console is CAB. Now, why does it matter? It matters because the RavenDB client is going to use the first node in the list as the primary point of contact. So all of the users who are using Northwind as their target, as the tenant ID, will try to use B always. All of the users using Contoso will use C always. Unless we have a failure of B on C, that's what they will do. So we have a very natural way of doing load balancing on a tenant by tenant basis. Now, if this is also applicable if you have per user load balancing, if you don't need to have consistency between users, then you can do that on the username, and each user will have a different topology that they will use. So different requests for different users would have a different primary node for the same database in the same client application. Now, why does it relate to consistency? What do you think? Let's consider a very common scenario. We have post, redirect, get. And that's how it goes. I'm doing a post to the server, and it sends a client-side redirect, and I have a get to the actual data. By default, RavenDB would accept a write and would acknowledge right after it was accepted, process and save to disk on a single node. There are ways to increase the guarantees that you have for write. You may say, oh, I want it on 2 nodes, 3 nodes, majority, all much of stuff like that. You can also use cluster-wide transactions, but let's say that you're using the default. And the default is once the write has been persisted to a single node disk, we will acknowledge that. Now, consider what will happen if I have the post redirect get system and I have random routing in my environment. The first request would go to node A, would store the data there, and redirect. At this point, RavenDB is going to replicate the change to the other nodes. But the client has been fast enough to get the data from node B before the replication is completed. What's going to happen then? At this point, we're stuck. At this point, the user is going to say, hey, I written my data. I got a confirmation for that, but then it went away. So by default, RavenDB direct read and writes to the same database, and you only have to deal with switching over to the other databases if you explicitly chose that when you use read load balancing and stuff like that. This is specifically to handle this scenario. Now, with the context load balancing, we ensure that the 2 queries on the same context will always have the same topology. And if they have the same topology, then we know that we'll always go to node B, because this is what node win does. And Contos will always know to go to C. So we don't have to worry about single node consistency. Hope this makes sense. In the case of a user, if you don't have to worry too much about, oh, I have instantaneous transmission from one user to another, then I can also do that on a per user basis and spread read and write load around my cluster. Now, how do we deal with shared data? What is shared data in this context? So tenant metadata, billing information, those sort of things. And I also have this application specific, what my system has been doing. Of course, all tenants, a good example here, maybe I want to show a percentage of failed orders across my entire system. What is my spam ranking, those sort of things. So let's see how it works. Even in the single shared database, you would typically have this on the side, on a separate database, because this is the application database. This is not something that belongs to the tenants. So you typically have it separate, but in the case of database per tenant, it would absolutely be a single global database across all of them. And that is how you manage the meta information. Makes sense. For the aggregation, if you're running everything on a single database, that's pretty easy. You know how to do that. If you're running that on database per tenant, you have to think about how this is done. And the easiest way to do that is to take a multi-step approach. We're going to say on each tenant, aggregate the information that we want for that tenant. We're probably going to want to do that on general for that tenant anyway, and to display reports for this tenant. But we also are going to be able to set up RavenDB ETL to send that summary information to a shared location. And then I'm able to take all of that information and aggregate it again. I've spoken about this in the past in the context of doing a geo-distributed aggregation if I have stores and I'm pushing data to the cloud, things of this nature. In this case, I'm using the same concept of RavenETL and aggregation, but in order to aggregate data across different tenants in the same cluster. And that's it. Any questions, stuff you'd like to know? While I'm waiting for questions, I would like to remind you that we are on the cusp of releasing RavenDB 5.0. Those of you who are on RavenDB Cloud, you can start using it right away. There is also the free option on the cloud that you can utilize. Some of the new features are the time series and the some of the new features are the time series. There is also data compression. And the data compression, we've tested that. We just recently got confirmation from some of our users that were able to reduce the size on disk by 61%. They moved from 430 gigabyte to 189 or something like that. So it's a huge reduction. And that also means that you're also able to take in the cloud, use less, use smaller, what's it called? Smaller hard disks, smaller volumes. And it's nice because you typically charge for that and we can reduce that significantly. Yes. We got some questions over email about this topic. So from Jason, can RavenDB natively encrypt with tenant-specific keys? And the answer is yes, if you use the database per key model, database per tenant model. George is asking how to guarantee high performance when searching data of different tenants in a big database. Put it in RavenDB, it will work. More to the point, a lot of that depends on what do you mean by big database. If you have a lot of users who are running a lot of tenants on a single shared database, it's going to work. And queries in RavenDB tends to be pretty fast. Your query is going to be a filter on tenant ID, and the information is going to be running on that. So I don't think that this is going to be too big a problem. If you're running on multiple separate databases, then you can use the technique that I described with moving to their own nodes and stuff like that. But another thing that you might want to do in many different tenants in a big database is to go with the context base, and that will allow you to spread the load in more general ways. We have Rick, who is asking different data, shared data handling, how to know when to what to show when. I'm not sure what this was meant to. I'm not sure what this was meant to ask. Rick, if you're here, please clarify. We have Samad. Can you talk about the automation of the ETL setup per tenant? Can you do that in code similar to indexes? Absolutely everything in RavenDB can be done through code. So let's see. I have Rider here. And let's say that I want to set up some ETL. Document store, maintenance, send. Put see RavenETL. Here we go. So this is I have a connection string and And now you have here somewhere a script. This is the connection that you use. Here are the transformations. This is where you put the scripts. The collection this applies to, the script, etc. So if you look at this and you look at the user interface, there is pretty much one-to-one mapping between them. So you can just use it like that. And you just put it where you put it and call it, and that's about it. We have an anonymous who is asking, what about cross-tenant OLTP? Can you explain what you mean by that? Do you want to have a transaction across tenants? Do you want to do what exactly? Please give me more information about what you want. Alexandria is asking, if we use per client database separation, the client comes and say, use a separate database that they host in your multi-tenant app, is there a way to do that in the current API or need to be handled in the app? Alexander, do you mean that they want to be in control of the RavenDB instance that you're using? If so, in that case, you would have to have a separate document store instance for that. It's still very easy from that perspective, because instead of doing this, you would have document store. Oh, sorry. Where is document store? Something like that. You have a dictionary of all of them. I wouldn't recommend that. The scenario where you own and operate the application, the Multitenant application, and they operate the database servers is strange and likely going to cause you issues. Why will it cause you issues? Because you're in half control of the system. And if they're doing something to the system, or we just upgrade, or we're running their own report, something, it's going to impact the system, and you have to do cross-organization investigation into what's going on. Those are not fun. Okay, Matthias, does the Node.js client have the same capability as the C# client to specify ETL in code? The answer is yes, and let's see that. Let's see. Okay. So, relations. Well, the answer is, second, let's make sure that we are on the right track. Yes. Okay. So here you go. Here is the ETL configuration. And it's pretty much the same thing. Just make sure that you're looking at the 4.2. And dear God, I hate NPM. Alexander, separate cluster, I said it can work. It's trivial to manage that. You just need to do a dictionary of listing. But that's operationally, that's something that I would try to avoid. It sounds like it's a recipe for quite painful systems. Okay, I think we are done with questions. If you want to know RavenDB even better, you can schedule a live demo by going here to RavenDB live demo, and we'll set up something with you. We also do that with users who are interested to explore specific systems and scenarios. And that's it. Thank you very much for showing up for the webinar, and we'll see you next time. Goodbye.